In the previous videos, we programmed Lambda functions using Java. Now we will create a serverless project that uses Lambda functions in combination with other AWS services. For this purpose, we are going to use the AWS Toolkit plugin in Eclipse to create a serverless project from a project blueprint. Then we will take a look at the source code and template files that are created in this project, and then we will deploy and test the application. I have opened my Eclipse IDE, and now I'm going to click on the little orange AWS icon to create a new AWS serverless project. Let's give it the project name Java blog and select the article blueprint. Let's take a look at the files that have been created for us in the Java blog project. Here we can see two Java Lambda functions, getArticle and putArticle. Let's take a look at the putArticle Lambda function first. As you can see in the comments, this Lambda function is supposed to be triggered by an HTTP POST request through API Gateway. And then we'll read the metadata from our HTTP request and store that metadata in a DynamoDB table record. Then we'll take the payload from our post body and store the payload in an S3 object in an S3 bucket. The table name, the table schema, the bucket name, and so on is specified up here. And if we scroll down to the Lambda function handler, we can see that it takes as an input an object of type serverless input, which you can see down here, and as return it expects a serverless output object, which you can see down here. If we take a look at these objects, they basically wrap around HTTP requests. So our input has, for example, a body or headers, query string parameters, and so on. Let's go back to the putArticle Lambda function handler and see what it does. The first thing that we can see here is that we instantiate a DynamoDB client and an Amazon S3 client. And we already prepare a serverless output object that we return through our synchronous function invocation. Then down here, we create a random UUID, which we use as a key name for our S3 object that we create to store the payload. We read the payload from our serverless input object that we retrieve in the function handler up here, and then we execute an S3 put object request with our article bucket name, which we set up here using environment variables, and we use the key name with the randomly generated UUID. And as input, as content, we read a byte array input stream from our content that we have retrieved up here. Okay, so in this piece of code, we store an object, the payload of our HTTP post body in S3 as a new object. And down here, we store or we create a new DynamoDB record using a put item request. And the put item request is performed on a DynamoDB table. The table name again is specified through environment variables up here, and some attributes which are specified up here. The attributes specify our hash key, the table ID. We'll set a randomly generated ID here. We're using a type string, and we reference our S3 bucket and the key of our S3 object that we store in the bucket. So in our DynamoDB table record, we reference the payload that we have stored in Amazon S3. So if we scroll down, after these two requests, we return or we set the status code on our serverless output object and set the body successfully inserted article. Let's take a quick look at the getArticle function. So the getArticle function is supposed to be triggered through an HTTP get event, and it reads the query parameter ID and retrieves the content and returns the content that we have stored in our S3 bucket as a new object and returns that as payload in our HTTP response. Let's scroll down a little bit. First, we do some validation on our input. So we expect that we have a query parameter that contains the article table ID name, which is ID. And if that is not set, we throw an exception. And if it is set, we use it to query our DynamoDB table, and we retrieve our item at that, our DynamoDB record at that ID. And we retrieve the key of our S3 object. So then we'll use then we'll retrieve the S3 object key from the item that has been returned through our DynamoDB get item request before, and then we will retrieve the content of our S3 object, and we'll set that content in our serverless output. Okay, another important file that has been generated with our serverless project is this serverless template file down here. Let's take a look at what we find here. So for our application to work, besides our Lambda functions, we also need an S3 bucket and we need a DynamoDB table. Up here you can see some parameters that specify the name of our S3 bucket, the name of our DynamoDB table, and configurations of our DynamoDB table. When we scroll down, we can see some resources that get set up through this template. First, the getArticles Lambda function. And the Lambda function has a policy that allows our Lambda function to read from the DynamoDB table and read from our S3 bucket. So here we restrict these policies to our table and our bucket in this application. And our putArticle function has full DynamoDB access and full Amazon S3 access. For a production application, you might want to restrict these access rights a little bit further. If we scroll down, then we can see our resource which specifies our DynamoDB table using the parameters that we have defined above. And here, as a last resource, we can see our article bucket using the parameters defined above. Okay, let's upload our serverless project using the Deploy Serverless Project button here. And we'll deploy it in the EU Central region in Frankfurt. This will create a CloudFormation stack with the following stack name, and then the CloudFormation stack will be used to provision the AWS resources, namely the two Lambda functions, the DynamoDB table, and the S3 bucket with the appropriate policies. Now our CloudFormation stack is now our serverless application is being created using the CloudFormation stack. Now, before we deploy our serverless project, we need to change one thing. Because all S3 bucket names are shared in a global namespace, we need to change this bucket name to something else, because some other person who uses the AWS Toolkit plugin might have already created this bucket. So just create a random string of numbers and hope that nobody else has used this bucket name yet. So don't use the exact numbers as I use here, use something random. And now we'll click on the Java blog and deploy serverless project. We'll select the EU Central region in Frankfurt, and as a CloudFormation stack name, we use Java blog dev stack. Now the Lambda function code has been uploaded to S3, and our serverless CloudFormation template is now used to create the stack of resources that we need. The Lambda functions, get article and put article functions, the DynamoDB table, and the S3 bucket, and the respective IAM policies, so that our Lambda functions are able to access DynamoDB and S3 for read and write operations respectively. As you can see, currently we are in progress of creating. Our Lambda functions have just, the IAM roles for our Lambda functions have just been created. Now our Lambda functions are being provisioned. This has completed. Our API gateway is set up. We are setting the permissions. And so now basically all the AWS resources specified in our serverless template file down here are used to set up and configure our application. And finally, everything has completed. If your provisioning process has failed, please make sure that you change the bucket name, because otherwise it will fail because it says something like this bucket already exists. Okay, let's head over to the AWS management. I have opened my AWS management console and I'm here on the dashboard of CloudFormation. As you can see, there is a new stack, Java Block Dev Stack, which I have just created through Eclipse. If we click on that, we can see the same information basically that we have also seen in Eclipse. The operations that got processed based on our template. Here we can also see the template file that was used. So basically another way to double check or to find more information in case your provisioning fails or there are other problems where you need troubleshooting. So now let's take a quick look at the resources that we have provisioned using CloudFormation, and then let's try it out. On the API Gateway dashboard, I can see that 2 HTTP endpoints have been created for GET and for POST requests, and they are integrated with our Lambda functions. So if I click on that, I can see the Lambda function that has been deployed. And if I go to DynamoDB, here we can also see a new table, Serverless Blueprint article table. And here currently there are no items stored yet. And if you go to S3, you can also see the S3 bucket that has been created. Let's go back to the API Gateway. And here you can see the URL endpoint that we can use to test our application using Postman. I have opened Postman and I'm going to paste the URL from our endpoint and select the post method. And the first request that I'm going to make, I'll make it with a simple plain text, hello, and send. Now we get back a message that looks like an error, but actually if we take a look at the raw message, it says successfully inserted article at ID so-and-so. So let's do a GET request using that ID. And this will return our hello world text. Let's try another attachment, maybe a binary. I have attached a JPEG file to my request. And this has successfully created another entry in DynamoDB and S3. Let's retrieve it. Now if we take a look on our AWS Management Console, we can see that 2 records have been written into DynamoDB, which reference the payload in our S3 bucket. And if we look into the S3 bucket, then we can see 2 objects here. One is the hello world string and the other is the JPEG file. If we go back to the CloudFormation dashboard, we can take another look at our CloudFormation deployment. We can select Other Actions and View Edit Template in Designer. And this will open a nice visualization. And this opens a nice visualization of the resources involved in our project. We could also download it by clicking on this button up here to download an image of our deployment. Last but not least, let's close the designer and let's delete the stack that we have just created so that we don't have to pay for the provision throughput of our DynamoDB tables. Let's click on Actions and Delete Stack. In this section, we learned how to use Eclipse with the AWS Toolkit plugin, and we use Java to create and test different Lambda functions. First, a Lambda function with a simple string input and output, then a Lambda function that is triggered through S3 events, and just now a serverless project that consists of 2 Lambda functions which write to or read from DynamoDB and S3 respectively. In the next section, we are going to take a look how to program AWS Lambda using Python.